Hello and welcome to a guide to Land Rover suspension calibration. This presentation will cover why and when the suspension needs calibrating, the pre-checks that will need to be carried out, some basic suspension fault diagnosis and how to correctly calibrate the suspension. All Land Rover models from 2005 use the same method when it comes to calibrating the air suspension. A calibration should only be performed if the ECU has been replaced, a height sensor is removed or replaced, a suspension arm to which a height sensor is connected is removed or replaced. There are only two faults that calibration will rectify: a missing calibration fault and articulation fault. Any other faults in the system will not be rectified by a calibration. It's very important that the suspension is in correct working order before we attempt to calibrate it. Using the AutoLogic, check if any fault codes are logged in the air suspension control module. Check the suspension mechanically for any worn bushes, damaged components, free play, anything like that. Check the height sensors move freely. A good way to do this would be to look at the dynamic data for the height sensors on the AutoLogic and raise and lower the vehicle, monitoring the height sensor readings as the vehicle goes up and as the vehicle goes down. If all the ride height readings look good, then we can safely say that the height sensors are moving freely at that point. Don't try to calibrate the suspension before you have rectified any faults. Let's run through the type of fault codes that you get with the air suspension system on our vehicles. There's two main types of fault codes: hard fault codes and plausibility fault codes. For example, a hard fault code might be exhaust valve general electrical failure. So we would probably go down the road of checking the component wiring, checking the ECU. We also have our plausibility fault codes. When we have plausibility fault codes, i.e. the ECU has asked something to happen and it hasn't happened, and that could be something like pressure does not decrease when venting gallery. I've asked the exhaust valve to open, but I haven't seen a drop in pressure. That would be a plausibility fault code. When we get the plausibility fault codes, the questions are: can you reproduce the fault? Can the system be operated using the diagnostic tool? Is there a problem with the air system? Are there any mechanical faults not letting the system do what the ECU has asked it to do? As with any fault on any vehicle, the first thing we do is we verify the fault. If a customer presents a vehicle to us and says the vehicle does not raise, we want to make sure that is exactly what the vehicle is not doing. So we verified the fault code. The next we should have a look at is what type of codes are stored. As we've touched on, is it a hard fault code? Is it a plausibility fault code? If it's a hard fault code, this should be investigated first, because a hard fault code may well be leading on to a plausibility code. If it was a problem with the vehicle raising, do we want to be checking for air leaks? Do we want to be looking at the air system? Do we want to be looking at the airbags? Does the vehicle sink? Anything like that would be some of the basic checks that we would do first before we started pulling stuff apart, taking things off and inspecting things. So I said we need to rectify the hard faults first. These are very common hard faults that we see on all models with air suspension across the whole range, and they are height sensor wiring faults, valve solenoid and wiring faults, pressure sensor and wiring faults, sensor valve supply faults, bus failures, ECU hardware and software errors. Now, the next few slides, I'm going to take you through some typical faults that you will see on the Land Rover vehicles with air suspension. Here we have a right rear height sensor fault. right hand rear height sensor signal voltage stuck whilst vehicle is driven. So the vehicle is driving down the road and we've got the tool on the vehicle and we're monitoring the 4 height sensors. As we're going down the road, the bumps, undulating road, things like that, we can see 3 of the height sensors moving and the rear right is stuck doing nothing. Okay, now there could be a number of reasons why this is happening, and these could be water ingress into the wiring harness or connectors, height sensor linkage disconnected, height sensor harness wiring short to circuit, short to ground, short to power, high resistance, height sensor failure. One other thing we've had is the height sensor seized, and air suspension control module failure. The air suspension control module failure is on there, but it's not as common as the other components that can give you that fault. Now, here is your wiring layout for your typical height sensor. Okay, we have variable resistor height sensors, or later vehicles will be using a Hall effect sensor. But whatever one you have, you'll still have a 5-volt supply, a signal, and a ground. Problems with the wiring, problems with the sensor mechanisms will all cause erratic signals to the height sensors. Okay, if we have a problem on the ground side, we check here, we'd find that there would be no ground, and then the best thing to do would be to continuity check between the ECU and the height sensor. If there's any open circuit, rectify is necessary. Another common fault that you may be presented with is a corner valve fault or crosslink valve fault. The valve blocks are pretty robust when it comes to the electrical side of it. They do leak air if you ever get presented with a vehicle that's dropping on one corner or one side or the back or the front. But they do suffer from a lot of wiring problems. Now, there are 12-volt solenoids in there, so your best bet is to disconnect the valve block, disconnect the connector at the ECU, and continuity test and load test between the ECU and the valve block. This is at the particular time where the wiring diagram comes in very handy for this type of fault code. So you're not trying to guess which wire you're trying to check. I could probably count on one finger how many valve blocks I've had to change electrically. It's mainly been wiring that's the problem. Another issue might be presented to you is a pressure sensor fault, C1A09-1C, pressure sensor signal. Pressure sensor signal voltage out of range, i.e. the ECU is looking at the signal coming back from the sensor and decided that is not within the range that I'm expecting. So causes of that: pressure sensor disconnected, pressure sensor harness wiring short to ground, short to circuit, high resistance, pressure sensor failure, air suspension control module failure. But the last one, I would say that would be pretty uncommon. Where would I start? I'd probably disconnect the connector, check the pins, check for corrosion. Is there any water inside the connector? That's looking okay. I disconnect it, the ECU end. While I've got it disconnected, the pressure sensor end, I do my continuity checks, my load checks between the ECU and the sensor. If that turns all out okay, I'd probably replace the sensor next and see what reading I've got. Okay, so the last slide on hard faults is bus failures. Now we're going to use this small example here. We've only got 4 modules on the network: instrument cluster, steering angle sensor, suspension, parking brake. But this vehicle has been presented to us with loads of cam faults on it. And as we can see from the diagram, we've stuck an open circuit in between the steering angle sensor and the suspension control module. Now, first thing we're going to do is we're going to plug the tool in and we're going to do a quick test, and we're going to find out what is communicating on that car. Now, depending on the location of the diagnostic socket, we may get an indication of what we can and what we cannot talk to. So if our diagnostic socket was between the steering angle sensor and the instrument cluster, when talking to it, we'd get comms to the instrument cluster and comms to the steering angle sensor, but no communication to the suspension and the parking brake. Likewise, if our diagnostic socket was between the suspension control module and the parking brake module, when we try and talk to it, we would be able to talk to the suspension control module and the parking brake, but not the instrument cluster and the steering angle. So just doing that little test may well give us an indication of what part the network is that we are talking to and what part that we aren't. It's a very oversimplified version of CAN, as everybody knows, but it's just to give you a little idea of how you may approach a bus failure fault, apart from doing the normal checking the resistance at the diagnostic socket. It's all about trying to make things happen a little bit quicker and spend less time trying to work out where the problem is located. Okay, we finished with hard faults. Let's talk about ECU hardware and software errors. Air suspension control module not calibrated. Air suspension control module has been set into manufacturing, calibration or tight tolerance mode. Both those scenarios will set the fault code C1A 00-54 control module. My advice is to check that the vehicle is not in manufacturing, calibration or tight tolerance mode before you try and do an air suspension calibration. If the vehicle's old and you try and do a calibration, it can take quite a while to get it through, and that would have been a lot of wasted time if the vehicle was only in tight tolerance mode. Next, let's have a look at plausibility faults. These include average heights do not change as it should, system pressure, compressor temperature and sensor activity. Okay, as I said earlier, plausibility faults are when the ECU has asked something to happen and has not seen the expected results. So let's have a look how this system works. I've got a schematic here and I'll just run through quickly the parts and how they work and stuff like that, so you can see basically what's going on and give you an idea of how a plausibility fault occurs. Now, as you see on the screen, this is the vehicle raising. So the red lines denote the direction of where the air is going. So just run through quickly. You have the front valve block, the rear valve block with your corner valves in. So you'll have the front right, front left, crosslink valve, rear right, rear left, crosslink valve. You've got your reservoir valve here in the reservoir valve block, and you've got the compressor. Now, models moving on, the valve box and that's slightly different, but the basic operating principle remains the same on all of them. So here you can see that the vehicle is raising. So the red line is the direction of the air. So as you can see, it wants to raise the vehicle. So the reservoir valve is open, both corner valves are open, and the air is coming out the reservoir, going through each corner valve and into the bag. Okay, that is basically the vehicle raising, and that is how the system works when the car wants to go from access to standard to off-road. Okay, here we have filling the reservoir. As you can see, that the compressor is trying to fill the reservoir. So what's happening is these valves in the front valve block are shut. These valves in the rear valve block are shut. The air can still get here, but the valves are shut, so it's going nowhere else. And all the air has been directed through the reservoir valve that is now open and filling the reservoir. So when we talk about the plausibility fault, pressure increases too slow when filling reservoir, what the ECU is doing is it's only trying to fill this reservoir. And so if we had a leak here, or between the compressor and the reservoir valve, that would log pressure increases too slow because the pressure is going out of here instead of filling the reservoir. Also, a sticking valve may well cause that because the valve is shut, the air cannot get into the reservoir quick enough, and it still comes up with reservoir filling too slow. Another fault code you may get with the sticking valve is pressure increases too quickly. And what is happening here, if you look at this unit here, this is the pressure sensor. Okay, so if the reservoir valve was stuck slightly, only open a little bit, what would happen here would be that the pressure would back up. Yeah, the pressure would rise quicker, and the ECU would then report pressure increases too fast. When I say to people you need to check for an air leak between the compressor and your reservoir, they say to me, yeah, but the vehicle's not dropping. But have a look at this. Why would the vehicle drop? All corner valves are shut, so there isn't any air escaping out the corner valves. There isn't any air escaping out the bag, so why would the vehicle drop? With pressure increases too slow, if the vehicle's not dropping down, you've got to check for an air leak in these places, here, here, and here, even to the fact where I've had reservoirs rotting out. So that would be another area where you will set pressure increases too slowly. Now let's talk about vehicle lowering. So the ECU wants to bring the vehicle down from where it's sitting at the moment, whether it be off-road mode or it be standard height. So what the ECU is doing is it's opened all four corner valves in the front valve block, the rear valve block, and it's opened the exhaust valve. The air is then being evacuated out through the reservoir valve block, but the reservoir valve is closed, so it's coming through there, through the compressor, out the exhaust valve, and then into atmosphere. That's the way the vehicle is dropping. Now, when you get the plausibility fault, pressure does not decrease when venting gallery. What's happened is the ECU has opened the exhaust valve and is expecting the pressure from the pressure sensor, which I showed you earlier, which is in the valve block, reservoir valve block, expects that pressure to drop. When the pressure doesn't drop, it logs pressure does not decrease when venting gallery. Now, the typical scenario is actually the exhaust valve is blocked in the compressor, but you could have any blockage in the gallery between the reservoir valve block and the compressor, even to a point where the exhaust out the back of the compressor is blocked, will log you that fault code. So what you could do is you could remove the two pipes from the reservoir valve block, try to bring the vehicle down and see if the vehicle comes down. Yeah, you could also remove the pipe that's coming from the reservoir valve block to the compressor. You could also remove that to atmosphere and try and bring the vehicle down. If you can break the system down into little pieces, we may find out where the restriction is. Okay, I'm just going to talk about the compressor temperature and the sensor activity. If you look at the left-hand box, you've got the temperatures. In there, you've got motor temperature and compressor temperature. So depending on what compressor you've got, would depend on what temperature sensor you've got. The Hitachi compressor had the motor and the compressor temperature. When they moved on to the later AMK compressor, they only had the compressor temperature. And what you want to use the compressor temperature for is if you get a plausibility fault that says compressor active but the temperature is not rising, there you would have a look to see what your compressor temperature is, because what the ECU is saying, I'm running my pump, so I'm expecting the temperature to rise. When it doesn't rise, it logs a typical fault like that. So what you want to have a look at is you want to have a look at the wiring to the temperature sensor. So that would be the wiring to the compressor or the temperature sensor inside the compressor. At that point, that's where you really need the wiring diagram, so you know what wiring that you're checking to the compressor. The right hand side is your ride heights. Now, depending on what unit you've got, you can change that to graphing. And when you're looking at those readings, when you go up, the readings should move up sequentially, and when it comes down, the readings go down sequentially. You're looking for any spikes, any dips. Does the reading drop out? to indicate that you may have a problem on one of the tracks, because the wiring may be okay, but you might have a burnt bit of the track or anything like that. And a good place to have a look is to either take the arm off the suspension and move the arm up manually slowly and watch the dynamic reading, or just run the car up, run the car down. Does it change at all? When you're looking at cross articulation faults, i.e. cross articulation means that the ECU is looking at the same height sensors across the same axle and looking at it and going, well, I'm driving along in this car, so I'm not parked on a curb or anything like that, and I've got my offside front height sensor reading 15, for example, and my near side front height sensor reading -5. That can't be right. I'm going in a straight line. Yeah. So you'd have a look at these height sensor readers, and see if you can look at what the actual count says and see if the count is massively out on one corner. Especially useful when you're driving along and looking at the count. Again, does it dip out? Does it spike up? Does it flatline? Anything like that to indicate there's a problem with that particular height sensor. Okay, let's move on to the calibration process. So I'll just read through this slide, and then I'll run through it. Okay, so you turn on the ignition, your autologic is connected, and you go into chassis, ride level control, standard height calibration. You're given the option of auto or neutral. You select neutral, which can be a tape measure. Read the on-screen warnings, select next. Start the engine and select continue. The air suspension ECU will open the crossing valves. This will level the vehicle left to right. Measure the corner heights from the centre of the wheel to the top of the wheel arch and enter the measurements in the autologic and press continue. So that's the basic overview on it, but I'll elaborate on it more. So we've got to calibrate this vehicle. So as I said at the beginning of the presentation, we've got to make sure that the suspension is in good working order. Yeah, and make sure everything regarding the suspension is no play, nothing falling out, anything that doesn't look quite right, is it level, anything like that. The suspension has got to be in good working order. So jump in the vehicle, use the height selection button inside the car, make sure the vehicle can go to off-road, make sure you can get to standard, make sure you can get to axis. Now doing that, going up, going down, would have changed the track a little bit. So what you want to do is you want to drive the vehicle around a little bit, level the suspension, let the compressor fill the air tank, because you're going to need a full tank of air, and then drive the vehicle into the flat level surface that you're going to calibrate this air suspension on. Okay. Now, Jaguar Land Rover do a tool. It's a very good tool. So if you're doing a lot of them, I would recommend you get it. If you've got to use a tape measure, my little tip is, if you cut 4 pieces of masking tape and you put them on the center of the hub and you draw a line on the masking tape, you're going to do measurements twice on this. So when you do the first measurements, you go from the line to the wheel arch, and when you do the second set of measurements, you'll be measuring from exactly the same place that you started in the first set of measurements, because the tolerance is only 3 mil. It's very tight. So you'll go through it, you'll go through the first set of measurements. You'll put the first set of measurements in, you'll press continue, and you'll notice that the vehicle will go up. Once the vehicle gets to its off-road height, you'll get another continue button, and you'll notice that the vehicle will come down. When it's down to standard height again, you will then be allowed to put in the next set of measurements. Okay? Put in the next set of measurements, all 4 corners, and you'll press continue. And if it's happy, it will calibrate the suspension. If it's unhappy, it will give you another go. So the vehicle will go up, and the vehicle will come down. You'll put the measurements in again. If it's happy, it will calibrate it. If it's not, you'll get a corner that it's not happy with. And then you'll get a fault code. That fault code we talked about earlier, C1A00-54. With that fault code in there, you can't do any more calibrating. So you've got to use the autologic and use the restore calibration data. That will restore some figures back to the ECU so you can clear the fault code. Once the fault code is clear, give it another try. This can be a very finicky process. Don't give up with it. Give it a few times before you think that there is an issue. Now, I don't know, if you've tried it 3-4 times and it still hasn't gone through, you're still getting a particular corner that's out that it's not happy with, perhaps it's then to start time traveling and look at the height sensor readings, looking at the height sensor, having a look as the vehicle is going up, going down, what is happening to the reading, can we see an issue? Because at that particular point, clearly there's something that the ECU doesn't like. But like I say, persevere with it. It can be tricky. Right, that comes to the end of my presentation. I hope you enjoyed it, and maybe you'll be able to listen to another one soon. Thank you very much. Goodbye.